Yes. So today we are discussing about influence line diagram, that is the model paper. First from the in this paper they have asked about compute the ordinates of influence line for reaction array for the beam shown at 1 meter interval and draw the influence line diagram. The moment of inertia is constant throughout. Okay, so you can see this beam. So this beam is of span AB is of 6 meters and BC is of 5 meters. Total it is 11 meters beam. Okay, so if the reaction is applied at RA is applied at A, then for this reaction which is applied over here, for that we need to find the influence line diagram. Okay, so and one more thing, it is given show at 1 meter interval. So we are supposed to give 1 meter of interval to the section. Okay, so coming to the first case, influence line diagram with respect to reaction A, that is RA. To find the reaction, we are supposed to apply 1 kilonewton of load. Okay, if we apply 1 kilonewton and we have divided all the span length into ordinates. Okay, this is first ordinate, second ordinate, third ordinate, fourth ordinate, fifth ordinate, 6th, 7th, 8th and 9th. Okay, totally the ordinates are fixed, and this is point B with reaction RB, and this is point C with reaction RC. Okay, and as we apply 1 kilonewton of load, so what happens is RA we are applying 1 kilonewton, so we want to calculate the reactions about RB and RC as well, so that we can draw the influence line diagram. Okay, to find the reactions about RA, RB and RC, then we are supposed to take sum of moments about point C are equal to 0. That is, about this point moments are equal to 0. So if we apply here, so RA into the span is of 11 meters, that is RA into 11 is equals to RB into 5 meters. Okay, so as we don't know RB, we know only RA, that is we are applying 1 kilonewton of load. So from this we can find the value of RB, that is equals to 11 by 5, which is equals to 2.2 kilonewtons. Okay, so we have got now the value of RB as well. So to find the value of RC, we know that sum of the forces acting in the frame are equal to 0. These are all nothing but the equilibrium equations. Okay, you need to know sum of forces along vertical direction are equal to 0, sum of forces along horizontal direction are equal to 0, sum of moments about any point are equal to 0. We are applying the same condition. So now next, sum of vertical forces are equal to 0. As this force is acting upwards, this is acting downwards, so we will take RA plus RB plus RC is equal to 0, that is 1 minus 2.2 plus C. So upward forces we are taking as positive here. Okay, and downward forces as negative. Okay, so from this we will find the value of RC, that is positive 1.2. so positive 1.2 is upward force which is acting. So after that we will find the bending moment. To find the bending moment, if you take about any point, that is from RC, okay, if you take from RC 1.2 into 5 meters, okay, that is you will get 6 kilonewtons, 6 kilonewton meter. If you take from RA into 6 meters, that is 6 kilonewton meter. So this is the maximum bending moment which we are going to have with respect to point C. Okay, so next, based on the bending moment to calculate the released moments, conjugate beam is formed. Okay, so far we have calculated the reaction, that is for applying 1 kilonewton of load at point at point A, we have calculated the bending moment and reactions with respect to different supports. So this is not enough. Moments is calculated, but we need to find out the influence line with respect to the reaction, how it forms. For that we are forming this beam into a conjugate beam. That is, for each and every ordinate we are supposed to find the moments. As we know that the moment is 6 kilonewtons, then as per conjugate beam method, we are supposed to find out the reactions. Okay, so far we have calculated only the original reactions with respect to the frame due to application of 1 kilonewton load, okay, at RA. Now we are finding the reactions with respect to conjugate beam technique. So here in this case we will take sum of moments about B are equal to 0. So that RB into phi is equals to half of, so this is the frame condition. So we are taking this frame to be as existing load member. Okay, this load member we are replying as m by EA, that is 6 by EA. So for this beam we are taking RA into phi is the moment. Now we are calculating moment for this frame. So to calculate the moment of this frame about this part, that is sum of moments about B are equal to 0, we are taking RC into phi into this section, that is about this. If you take half into phi is the span distance, sorry, half of phi into the load, okay, that is 5 meters about this point. The load is 6 by A into 1 by third of length is the center of gravity. To calculate the moment we will take CG as distance. So CG for this is from the right hand side, it is 1 by third of the length, that is 5 meters. So totally we will represent as 1 by 2 into 5 into 6 by A into 5 by 3. Okay, with this we will find the value of RC, that is 5 by EA. Okay, next, sum of forces along vertical direction are equal to 0, that is RA plus RC equals to, here we have released B, there is no supported B, only the load is acting about B. Okay, that is why we did not take in the conjugate beam, we are releasing this member. Okay, so that is why R dash A plus R dash C is equals to, the load which is acting on the total frame is half into L into 6 by E, because this is acting towards left as well as right. So if you take from the left hand side, it is 2 by 3, it is 1 by 3, so totally we take it as 3 by 3, that becomes 1 into 11 is the span, beam span, into 6 by E is the maximum load applied. Okay, that is half into 11 into 6 by E. Now R dash A is equals to 33 EI minus 5 by EI is equals to 28 by A. So this 33 we have got as from this value, that is half into 2 ones are 2 3s are 11 into 3, 33 by EA minus, as RC is 5 by 3 EA, that we have substituted over here. Okay, so it becomes 28 by EA. Now we have got RA, RC as well, but due to the application of 1 kilonewton of load here, there is a moment generated, yes or no, in the conjugate beam, that is due to this load of 6 by EI about this load. We need to calculate the moment generated about MA. So that is M dash A is M dash A plus 5 by A. Moments about A we are calculating. So that is the moment generated, that is M dash AB plus 5 by A into 11. That is reaction RC dash into 11 minus 1 by 2 into 11 into 6 by A plus this is 11 by 3 plus 6 by 3. Okay, we are taking about the total span and this span as well. This you can write it as 11 plus 3 by 11 plus 6 by 3, that is equals to 0. So M dash AB will become 132 by EA after simplification. Next, as we have calculated the moment generated over here due to application of 1 kilonewton load, then the conjugate beams comes into, now we are supposed to go into drawing the influence line diagram. Okay, taking moments cause tension at the bottom as positive and one causing tension at the top as negative. So moments which are causing at the top we are supposed to take as negative, and the moments which are causing at the bottom you are supposed to take as positive. Okay, so first case, MA is equals to minus of 132 by EA, that is from here, what are the value, that is equals to minus 132 by EA. MA we have got, M1 is nothing but, here we have developed 9 ordinates. Okay, for each ordinate we are finding the values, that is first M1 is the ordinate with respect to 1. Okay, so that ordinate we are taking here, that is equals to minus 132 by EA plus 28 by EA into 1. 28 by EA is the reaction RA. Okay, reaction RA into 1 minus 1 by 2 into 1 by A into, as we have applied 1 kilonewton of load, so about this ordinate. So here what we are doing is 6 by EA is the maximum load which is applied. So at ordinate 1 it is 1 by A, at ordinate 2 it is 2 by A, at ordinate 3 3 by A, 4 by A, 5 by A. Whereas if you go for this set, it is multiples of 1.2. So at first ordinate 1.2 by A, 2.4 by A, next 3.6 by A, and 4.8 by A. The same values we are applying the load over here into 1 meter into 1 by 3. Okay, so next case, that will give us the value of minus 1.4.33 by A. Next, M2 is equals to minus 132 by A. This is with respect to, as so far when we are dealing from A to B, MA exists. If we are dealing from B to C, we consider C values, as CMC is not over there, so it is considered to be as 0. So when you take M2, minus 132 by A plus 28 by A into 2 minus 1 by 2 of this 2 is from RA to the distance 2 meters, that is second ordinate. Okay, minus 1 by 2 into this. If you see why we are taking 1 by 2 is this triangle with the second ordinate or first ordinate or whole triangle will take half of the section into length into breadth. That is the formula for triangle. Okay, load formula for triangle. So that we are taking minus 1 by 2 into load. Horizontal distance is 2 meters and vertical distance is 2 by A into CG, center of gravity. We are taking the body about center of gravity, that is a 2 by 3 into 1 by third of the 2 meters. Okay, is equals to minus 77.33 by A. Similarly, M3 is equals to same, minus 132 by A plus 28 by A into third ordinate 3 minus 1 by 2 into 3 into 3 by A is the load about that point, and 3 is the distance by 1 by 3 into 1 by 3, that is minus 52.5 by A. Same way M4 we are doing, and M5 also we are doing same way. Okay, after that when you go for B, C, then we don't have any moments about C, that is why it is 0. So directly we will take M9. From the right hand side we are coming. Okay, from the support side, that is 5 by A into 1 minus 1 by 2 into 1 into 1.2 by A by 1 by 3. Thus will give us 4.8 by A. M8 is equals to 5 by A into 2 minus 1 by 2 into 2 into 2.4 is the load at second ordinate into 2 meters at second ordinate. Okay, here we need to remember one thing, as the span is of 5 meters, the distance will be 1 2 3 4 5. It is not multiples of 1.2. Okay, so 1 meter, 2 meter, 3 meters and 4 meters. Okay, next 2 by 3 is equals to 8.4 A. Next M7 is equals to 5 by A into 3 minus 1 by 2 into 3 into the load is 3.6 by A at that point vertical into 3 into 1 by 3, that is equals to 9.69, whereas M6 is equals to 5 by A into 4 minus 1 by 2 into 4 into 4.8 by A into 3 is equals to 7.2. Now we go for drawing the influence line diagram. This is how we draw the influence line diagram. At point A it is same, that is minus 132 by A divided by 132 by A. Okay, this will give us 1. Whereas for the second case, that is odd net 1,